All right. So we're going to pick up where we left off yesterday. And we're going to get more into the details behind graphing these types of functions. So we've talked really briefly about how to find the horizontal and vertical asymptotes, how to graph those on your graph. And then yesterday we talked about like those two parent functions for like the most common cases of these types of functions. However, they don't all look like that. Or sometimes they get really complicated and it's maybe more difficult to even just try to use the parent function because you're having to think about all the movement that happened, and it can be really challenging to figure out all those little pieces. So today we're going to go over the situation where if you're just given a function, how you kind of find everything that you need to find from scratch, and you just kind of start working your way through it. So the steps would be to like figure out what your asymptotes are, that horizontal one, the vertical one, like being able to think about those things. And then we'll also talk about using our tables again to help us find some points so that we can sketch what this graph is going to look like. Okay, so we're going to start with this example. And again, they are kind of going backwards from what we would have talked about in class because we started with talking about vertical ones first and then horizontal, because remember I made that mistake yesterday. So they are switching it on us here where they're talking about horizontal first and then vertical. So just keep that in mind as we get working through this. All right, my first example here says 3x plus 3 over x squared minus 16. This is kind of like our bell ringer a little bit because we're looking at those original first two terms and the degrees. The degree on the top is a 1 and the degree on the bottom is a 2. How could this simplify, this 3x over x squared? Good, 3 over x. If the x is still on the bottom like that, that means that that top one had a lesser degree than the bottom did. So this would give us a horizontal asymptote at y equals 0. Okay, so I'm going to come over here to my graph and I'm going to put that on. Remember, this would be going through the point y equals 0, which is just going to be along the x-axis. So this line would just be right on top of that x-axis. Now, the vertical asymptotes, I think, are a little bit more crucial because these are your boundary lines. So these are the lines that your graph cannot be crossing these points, okay? And that's when you set your denominator equal to 0. Our denominator here says x squared minus 16. So they've got that set up down here. How would you guys solve that? Yep. So you have x squared equals 16 and then square root. And what is that? Plus or minus 4, okay? And that's why they said in that note that there's two of them. So you have to go to positive 4 and negative 4, and you have to draw vertical dashed lines, and these are going to be those boundary lines. All right, so we've kind of got our horizontal and vertical asymptotes taken care of. Now we need to figure out where does this graph actually lie? Like where are some points that we maybe need to put in here? So what they're suggesting that you guys do down below is they're giving you like a table to fill in some numbers. And they're saying to find some points on each side of the asymptotes. So that would be that 4 and negative 4. So if you think about a number line, or even just think about your x values here, negative 4 would be between negative 5 and negative 3. So in my table here, I'm going to start with x values at negative 5 and negative 3. What numbers would positive 4 be between? Close. Positive 4 would be between 3 and 5. Okay, so if you have your calculator, you're going to hit your table button. Okay, you're going to type in this equation here, 3x plus 3 all over x squared minus 16. Type that in, make sure you're being extra careful with how you're typing those things in. You're getting everything in the right spot. Okay, so type that function in. You can start it at -5 if you'd like to, because those are the points that I really care about. Now, you may not get nice numbers. Chances are pretty likely you're going to be dealing with some really gross decimals here. All right, but we're still going to write them down because we still need to graph them. And we'll just have to estimate where we think they are. So can you guys help me out here? What'd you get at -5? I agree, but do you have a decimal at all?
No. Oh wait, I can.
You can change it, right? Be -1.3 repeating, right?
Yeah, I guess.
So I'm just going to say -1.3. I'm just going to round it because I don't need to know like exact right now because I am graphing, so I'm going to be doing some rough guessing where it is. How about at -3? 0.85 you said? I'm just going to round it to 0.9 then. How about at +3? Okay. And at 5? 2. A nice one there, at least. Okay, so now we're going to graph these points. So -5, and then you're going to go down -1.3-ish. Okay, I'm going to zoom in on the graph here. We're going to do the best we can with these. So that's about there. Then we had -3, we said was at 0.9. We said 3 was at -1.7. And then 5 was at 2. All right, so I've got those points put on my graph. Now we just need to figure out how to draw this so that we understand what it's going to look like. Now, if you need more help, you can still grab more points from your table. You have the table there in front of you. You could start looking at other points, like you could see what does it do at -6? What does it do as it starts to get closer to that -4? Or you can look at even some of these numbers in the middle, like what's it doing at 0, 1, 2, -1, -2. When I think about what this looks like, and I use some of my information or like my prior knowledge to what we've even seen prior in our notes, like with our parent graphs and that, remember those vertical asymptotes are your boundaries. So your graph is not going to hit that. So I'm talking about like up here, this point. This is going to kind of go up this way, but it's never going to cross this line. And as it comes down, it's going to start to kind of go along this horizontal asymptote as well. So use those lines to kind of help you figure out where your boundary should be. What's your confused look for?
Shouldn't the point at 1.7 be -1.7?
At 3?
Yeah.
It is. 3, -1.7.
Okay, I'm gonna draw one.
The -3 I had at 0.9. Was it negative or was it positive 0.9? Okay, so like I was saying, this is going to kind of go up and it's going to come this way. That'd be like a branch. Now, the other side, kind of down by that -5 point, that -5, -1.3, that side is going to behave the same way, but it's going to be more so like down. It almost looks like a reflected image of what we just graphed. So it's going to look like that. Now, let's talk about what happens in the middle here. Okay, those middle points are going to need to be connected. But as we get closer again to that asymptote line, it's kind of going up, but it's never going to cross. So I'm going to have this kind of get really close, come down and hit that point. It's going to continue to travel over here. It's going to kind of slant a little bit, and then it's going to go down. Now, if you can't see where those lines should be going, that's when I would suggest that you guys use some more points from your table. Even just tell me where on your table is 0 at? -1. Is that what you said? Okay, so mine's off just a little bit, but this point should be right there. So you could add more if you need more information to help you connect those points. You can add as much as you would like to help you maybe graph it better. You don't have to just do 4 points like I did. especially as maybe you're trying to figure things out. Maybe using more than one thing would be helpful. All right, do we have questions on that example?
You get the general idea though, if we didn't put more points though, right?
Right. I would say as long as those branches are facing the right direction, oh, that should have an arrow. You're going to be fine. Okay. I'm just saying if you need more because you're not sure how they should face, go look at more points and see what they're doing. Okay, let's do another one. Okay, let's start by finding our asymptotes here. So let's begin with, if I just keep it in the same order as before, the horizontal they did first on that last one. So that's when I set 3x over 6x. How does that reduce? 1/2. Okay, so when they're equal degrees, this number, this fraction that you got here is going to be your horizontal. So we're going to have a horizontal line at y equals positive 1/2. Again, it's a decimal, so you'll have to just guess where you think that is on your graph. So I'm going to come over here. I'm going to go up 1/2, and I'm going to draw a horizontal line. So that was for my horizontal. Now let's do vertical. Vertical is when you set the bottom equal to 0. If you guys set that equal to 0 and you solve for your x, what do you get? 2. So x cannot equal 2. So I'm going to come back over here now. I'm going to go to 2 on the x-axis and draw my vertical line through it. Whoa. We only had one vertical this time because there was not like a squared or anything. So this is almost similar to that parent function that we talked about yesterday, in that it's got like a 1 horizontal and 1 vertical. All right, so now what I need to do is try to find some points, and we do that based around our vertical asymptote here. So I'm going to make just a little tiny t-chart. Okay, sometimes what I'll do is I'll put 2 in the middle and I'll just like draw a dash through it because that's where it would become undefined. And then that lets me know I need to find numbers on either side of 2. You could do as many as you want. Okay, but 2 is in between 1 and 3. So now go to your table. You're going to plug in this equation here. And I need you to tell me what you get at 1 and 3. -1 for 1 and 2 for 3. Good. So then I'm going to graph those points. So positive 1 is at -1. And 3 is at 2. Do you guys know how this is going to look? Can you describe what the branches look like? Okay. I think I got what you're saying.
Upside down, right?
Is this what you were saying?
Yeah.
Yeah. Perfect. There you go. All right, great job. Questions on either of those two? Okay. We talked about slant asymptotes just a little bit yesterday, mainly in just like how to identify if a function has them. Remember, a function has a slant if the top degree is bigger than the bottom degree. Okay, so what we need to do is talk about how do you do that on a graph though, because we haven't really seen any cases like that. So far, we've only been dealing with like your traditional horizontal, vertical stuff. So on the next page, we're going to talk about how to work with these slant asymptotes here. This is when that degree is on the top, one more than the degree on the bottom. So like you'd have an x squared on the top and an x on the bottom, or an x to the third on the top and an x squared on the bottom. That's how we identify if it's going to have a slant asymptote. The horizontal slant, how to find it, or sorry, I said that wrong. How to find the slant asymptote is you're going to be using some of the stuff that we did in the last section, like some of our synthetic or long division. Now, I would use synthetic because it's faster. And we're only going to need to do that to find one little piece of information. We don't need to use like this whole big polynomial for anything. But you can see what they did is they took this problem up here that said 2x squared minus 5x plus 7, and that was being divided by x minus 2. It looks like those division problems that we saw before. So what they did down here is they're using synthetic division to help us. So remember to do synthetic division, whatever you're dividing by. In this case, it's x minus 2. You take the opposite sign of that number. So that's why they put positive 2 in the box. Then they grab their coefficients from that equation along the top. The 2, the negative 5, and the positive 7. All of that is written down below. And then they did their synthetic division stuff. So they dropped that first 2. 2 times 2 is 4. They added that to that negative 1 or negative 5. They got negative 1. And then they repeat the process. Okay, these are your new coefficients. And so they wrote that over here where it says 2x minus 1 plus 5 is your remainder. When you're dealing with the slant, you guys get to ignore the remainder. And you only have to graph the line that you came out with. That's like the clean, depressed polynomial. So in this case, it would be the 2x minus 1. We're going to graph that line. So I'm going to stop here for a second. I'm going to come to my graph, and I'm going to graph this line y equals 2x minus 1. Now, this is going way back to your algebra days. Do you guys remember how to graph a line like this? Where do you start? Nope, it's already ready for us to graph it.
Up to
Okay, that's your slope. Where do we start it at? At negative 1 on the y-axis. So you're going to go down negative 1, because that's like our y-intercept. That's maybe known as your b. This is in slope-intercept form. Y equals mx plus b. B is negative 1. So you go down 1. If it was positive, you would go up 1. And then she said the slope was 2 over 1. Do you see where she got the 2 over 1 from? It's that number in front of your x. 2. But how do you write 2 as a fraction? Over 1, because we're thinking rise over run here. So from negative 1, you guys need to go up 2 and write 1. And you can do that as many times as you'd like. You could also go down 2 and left 1 if you want to go the opposite way. But that's going to start to show you where your slant asymptote should be. So I'm going to go ahead and draw that in. And again, I'm still just going to have it be a dotted or dashed line. Okay. Now let's find the vertical. That's when you set the denominator equal to 0. Okay, so if this is your denominator, x minus 2, if we set that equal to 0, we're going to get that x cannot equal 2. So coming back over here, I'm going to go to 2 on my x, and it's going to go up and down. So it looks like we've kind of created an x on our graph here with those slant and vertical asymptotes. Now we need to find some points that are on either side of the vertical. So we said the vertical was 2. So what numbers is 2 in between?
3 and 1.
3 and 1. Okay, so now you're going to go to your table. Okay, type in that equation that we started with at the very beginning here. So way up here to what I circled in green, that 2x squared minus 5x plus 7 all over x minus 2. You need to tell me what my numbers are for 1 and 3. Good news is they should be whole numbers. Negative 4 and 10. Good. So now I'm going to graph those points. So 1 goes down to negative 4. 3 goes to 10, which is going to go off my graph a little bit. Again, if you need more points to help you graph this, you can. But what these ones are going to look like is they're going to be kind of stuck in between those lines. So they look a little weird. But so like this one's going to come down, and then it's going to make like a sharp U-turn, and it's going to go back out that way. And the same thing's going to happen down here. This is going to kind of go up through this point, and then it's going to make a U-turn, and it's going to go back down.
No, that's not.
They're a little weird. So this is what it looks like graphically when you guys were doing all that division in the last section, or in section 3, I think is when we did dividing. That's what those things look like when we put them on the graph. Sometimes, like, you know, if they're factorable, they maybe become a little bit simpler, but this one's a little bit weird. All right, we're going to do one from scratch together. So first thing we need to do is figure out what our slant asymptote is. So we're going to start there. If I can spell it right. Okay, so this is when you're going to do your synthetic division. What's the number that we're going to put in our box? Positive 3, good, because the bottom says x minus 3, so you're going to put positive 3. What are my coefficients from that polynomial across the top? Very good. Okay, so I've got my numbers here. This would become x minus 1 and then minus 8 over x minus 3. But remember, I don't really care about the remainder. I just need this piece. So the line I'm going to graph is y equals x minus 1. So how should I graph that? Start at negative 1. What's your slope? 1 over 1, because remember there's a 1 in front of the x. So you're going to go up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, so on. Whoops, I'm going. There we go. I skipped a point when I did mine originally. And like I said, you can do this as many times as you'd like. You don't have to do it as many as I am. Okay, so there's your slant line. Now let's find our vertical. How do we do that? What do we use to find our vertical? Denominator. And you set it equal to 0. And what do you guys get? 3. So x cannot equal 3. So I come over here to positive 3 on the x and draw a vertical line going up and down. So I've got those taken care of. Now I need to find a couple of points. And we do this based off of the vertical. So again, you can put 3 in the middle if you'd like to and just say that's where it's undefined at. What is 3 in between? 2 and 4. And now I need those numbers. So you're going to plug this into your table to find those numbers. Or you can do it manually too if you want, but that might be more of a hassle. Good. Okay, so these points are a little bit in a different area. They're still going to act the same way. This is just it's still going to turn on itself and make like that U-turn. It's just not going to be as sharp on this one because it's not stuck in between the narrow parts of the graph. So it's still going to come down and then it's going to just start to travel along those asymptotes that we have on our graph. So a little different because the last one we did, they were stuck in more of the skinnier part of the X. This one's in the more wide area. All right. Any questions on graphing with the slant? Okay, we've got one last thing to do. We are almost done, guys. You can do it. Okay, the last thing we're going to do, we're not graphing. Okay, hallelujah. What we're going to do here is we're going to figure out how to work with a function that kind of represents this idea. We're talking about like how much it costs something to be manufactured and like what they should maybe sell it at. So this example is saying that a company is planning to manufacture wheelchairs that are light, fast, and beautiful. The fixed monthly cost will be $500,000, and it will cost $400 to produce each of these chairs. First thing that they did is they wrote a cost function to represent the situation here. So C of X just represents the cost of selling or producing X number of wheelchairs. 500,000 is the initial cost no matter how many they sell or not. So if they sell 0 or if they sell 1,000 of these chairs, they have to fork over $500,000 to even begin. Okay, that might be like just their startup cost. It takes care of all the materials that they have to put in first, whatever. Now the 400X, that's your slope here because the 400 is how much each chair is going to be sold for. And so we're going to have to figure out what's the differences like when we start thinking about if they sell different numbers of chairs. So the average cost is the bar above C in average notation. So when we talk about average, we're figuring out like what's the mean price that these things should be sold at. To do that, you're going to take your formula that we just figured out from reading our problem and you divide it by X, because X would represent the number of chairs sold. So anytime you're finding the average, you always take it divided by the number of items that you're looking at. So if I wanted to find your guys' average quiz score, I would add all your quiz scores together, divide by the number of quizzes that I had. That's what's happening here. So they want us to find the average cost if they produced 1,000 wheelchairs. So 1,000 is going to be what goes in for the X, and it's going to go into this formula here. So you're going to take 500,000 plus 400 times 1,000 over 1,000. The other thing you could do, if you still want to use your table, is you could type in that function, 500,000 plus 400x all over x, and you could start your table at 1,000, and it'll tell you a number. So you can type it in like this, or you can still use your table function. Okay, so tell me what you got for a number. 900. So this is going to be in dollars because we're talking about cost. So what that means is if they sell 1,000 wheelchairs, they have to sell the wheelchairs at $900 a piece in order to like break even here. All right. What if they up it to 10,000 wheelchairs? What if they get 10,000 sold? How much should they market each one for now? How much?
You said 10,000?
10,000 instead. Yep. What'd you get? 450. Okay, what did that do to the cost? It cut it in half, okay? So instead of doing 1,000, now we're up to 10,000, it cut it in half, okay? Let's see what happens though if they sell 100,000 wheelchairs. What does that come out to be? 405. Okay. Now I'm not asking for more, but if you continue to increase the number, it's going to start to get closer and closer and closer to this 400, because that's what they set up above was like that average amount that it costs to create this thing. That was that slope. So that I'm going to say when they're asking like, what's this horizontal asymptote? Like eventually they're never going to get to a point where they're selling something for $0. Okay. Because then you're not working your way through the profit there. So what they're trying to have you guys figure out here is the more wheelchairs that they sell. So even if you put in 200,000, 300,000, 400,000, you're going to get closer and closer and closer to 400. It's never going to go below 400 because that's an asymptote. So it's like a boundary for you. So we're going to say down here, my horizontal is going to be y equals 400. Okay, what does it mean? The cost approaches $400 as more are produced. So even if you put in $1 million, you're going to get really close to 400. It may not come out to be exactly 400, but it's going to start to get really, really, really close to it. So you're going to get like 400 point, maybe a bunch of zeros or something like that. Okay. All right. That is it for notes.